right. Okay, and we're live. Check, check, mic check. Check, check, mic check. Good afternoon, everybody. Welcome into another live stream. My name is Dr. Andrew Sanchez, aka Dr. Drew. And let's see here. Guys, we're going to go ahead and do our problems right away today. Dylan, welcome into the chat. Guys, question of the day. We got to jump right into it today. Question of the day. What topics should we cover today? Let me go ahead and pull up this poll here. Guys, how's everyone doing? Juan, welcome in. Good to see you. Isaac, welcome in. Well, let's do our custom poll. And let's do 20 minutes on the clock today because I don't have all too much time today. What topic should we cover today? Is it going to be A, general chemistry, B, organic chemistry, C, physics, or D, calculus? Tap the top left-hand side of your screen to let me know what topic we should focus on today. I'm chilling, bro. I'm absolutely chilling. Okay, it's definitely busy for midterms and students, so that's why I'm out here. Okay, doing my little live streams. Okay, so the poll is active, and then let's bring that up and pull up the website. We're gonna do 5 minutes on the clock, and then we'll get started right away. So before we do, I'm gonna go ahead and share my screen. Make sure you vote up on the top left-hand side of the screen, and we'll get started shortly. All right, we gotta jump right into it today. No waiting. Let's see if there's any folk here. Okay, good afternoon, everybody. Welcome into the chat. My name is Dr. Andrew Sanchez, PhD in Chemical Engineering. If you're new here, comment the word new so that we know that you're new. And if you've been here before, comment the lock emoji because you know we're about to lock in. As you can see, I have my website open here. It's engineeringminds.co. So I'm out here doing live STEM practice problems for organic chemistry, mathematics, calculus, gen chem, and physics. If you have any questions regarding those subjects, I do offer private tutoring for those various STEM subjects. I got you for gen chem, OChem, math, AP Chem, college physics, general physics, calculus-based physics, calculus 1, 2, and 3, algebra, pre-calculus, engineering. And yeah, so you can sign up for a free consultation call by going to the website, link in bio. That's engineeringminds.co. Click on this link that says book tutoring. The first session is totally free. And you can also explore the resources. We're just adding this resource page with various resources for mathematics, chemistry, physics. Okay, super excited to be building that out. Claudia, welcome in. Good to see you. Anton, Mason, Joey, welcome in. Next up, we have the join Discord button. So if you want to join the Discord, you can access free practice problems and interact with students and ask questions to get free homework help daily. And last but not least, if you want to ask your questions to get answered directly on today, you're gonna click that TikTok Q&A button and drop your questions in there. Guys, as you can see, we have our question of the day today. What topic should we focus on today? So make sure you tap on the top left hand side of your screen and vote for the topic that you want to work on today. I think we're going to go ahead and do our usual. We're going to start off with Gen Chem for the next 15 or 20 minutes. Don't have too much time. And I think I'm going to jump right into it today, guys, because I don't have too much time today. And yeah, guys, let's jump right into some stoichiometry. Once again, my name is Dr. Andrew Sanchez, PhD in Chemical Engineering. If you're new here, comment the word new so we know that you're new, and we'll welcome you in. And if you've been here before, comment the lock emoji because you know we're about to lock in. All right, guys. So let me bring this here and let me lock this. Okay, guys. So the first topic today is going to be Gen Chem stoichiometry as usual because I know that's a really common question. So if stoichiometry is a good topic to go over, comment a thumbs up emoji. Comment a thumbs up emoji if you think stoichiometry is a good topic for today. Okay, I'm gonna basically just jump right into it. And then I'm gonna do a practice problem here. And then let's share this. Chatter off, good to see you. physics. Guys, make sure you vote up on the top left hand side. Joey, I don't have fluid mechanics, but I saw your question. I'm gonna answer that shortly. Okay. I think you were the one that asked about the fluids question, right? Calculus 3. Guys, the plan here is we're gonna lock in for, let's see, let's check the poll. If one is overwhelmingly positive, then we're gonna jump right into it. But let's check the poll here. What's the first one here? So this time I'm seeing lots of calculus and physics today, so maybe we'll skip the Gen Chem. Oh, okay, we got 2 for Gen Chem, 2 for OChem. Guys, if you want me to do your topic, make sure you vote on the top left-hand side of the screen. So we got 2 for Gen Chem, 2 for OChem, and make sure you invite your friends to the live so you can help vote, and then we'll go over that for the next hour. Okay, guys, so the topic today is going to be stoichiometry for the next 15 minutes, and then after 15 minutes, whatever is the winner will be the next topic. So we're going to do our usual Gen Chem for stoichiometry. Nadia, welcome in. Red Bow SN2 reactions, I would love to. So Gen Chem is first right now, and then OChem is up on top. So who's gonna win? Okay, so we're gonna do Gen Chem for the next 15 minutes, and then whoever's the winner, we're gonna do that next topic. So again, make sure you invite your friends to the live. Tell them to vote up on the top left-hand screen. Got 14 minutes on the clock. Great. So we're gonna do a Gen Chem stoichiometry. We're going to do a Gen Chem stoichiometry problem. Okay. Okay. So I'm going to give you this reaction here. This is a stoichiometry problem for starters. And after 13 minutes, 14 minutes, we're going to see who's the winner. Okay. So we have this stoichiometry problem here, and I'm going to tell you what is given here. I'm going to tell you what is given here, and then what is going to be our final calculation. Cool. All right, cool. Yeah, absolutely. I do private tutoring. Okay, if you need help for OChem, you can either sign up for a free consultation call, the link in my bio, or the group tutoring. All the information is in the link in bio. Go to engineeringminds.co. All right, cool. So basically we have this reaction here, guys. So let me tell you what is given. So in the problem statement they gave us, they said a student is mixing 127 grams. Okay, a student is mixing 127 grams of calcium phosphate and 71.9 grams of H2SO4. And we want to calculate, what we want is the grams of H3PO4. What we want is the grams of H3PO4. Okay? So we're going to calculate. Okay, so guys, the first topic for today, for the next 10-15 minutes, we're going to start off with stoichiometry. So stoichiometry, if this general chemistry stoichiometry practice problem is a good topic to do, drop a thumbs up if we're about to lock in for stoichiometry. Okay? We have this problem here. Drop a thumbs up if you're ready for stoichiometry. Drop a lock-in emoji. Get out your notes. Try to follow along. And get out your calculators. TikToker, convert grams to moles and use mole ratio to convert it to grams. All right, that's perfect. But we have one problem. We have to, Nadia says locked in. Thank you, Nadia. We have to convert this into, we have to balance the reaction, okay? So how are we going to balance the reaction, guys? Before we do anything, we have to balance the reaction. Okay? So how are we going to balance this reaction, guys? So let's calculate our calcium here. I have 3 Ca on the left-hand side here, right? I have 3 Ca here on the left, and then I have 3. I got to do a 3 on the right here, right? So I did a 3 on the left and a 3 on the right so I can balance it out. I'm in honors chem high school. How do I memorize material and get it through my head? Merity, you don't want to memorize by like blindly like using flashcards and things like that and like watching videos. No, you got to do active recall. Active recall means you're not going to blindly, don't be watching this on your phone in your bed. Okay, if you're on your bed right now scrolling on your phone, get off your bed, get out your notes. Pretend this is an actual exam. That's going to get it into your brain. Okay, guys, the vote is on the top left. So you want me to do your topic, vote on the top left and invite your friends. So I balance my 3Ca and then I have to balance my P. I have 2P on the left, so I got to do 2P on the right. Okay. And then last but not least, I have 3 sulfur here, so I gotta add 3 sulfur here. And I think we should be balanced here. Guys, if anyone has any other tips for memorizing for chem, drop them down below. Great, so I'm gonna double check this here. Ca3, Ca3. And then PO42, PO42, that's good. H2SO4, I have SO4, 3SO4. I gotta check my H's here, so I have 6H here and 6H here. So this is balanced. Guys, if you understand how I balance this reaction, go ahead and drop a thumbs up. Justin, just list. Thank you for the rose. Memorization is chem class. Practice takes practice, chem teacher. Welcome, Pearl. Thank you for the thumbs up. I'm so confused on how to figure out the ionic charges. Make sure you check out my YouTube video where I talk about ionic charges. TikToker and Nadia, thank you for the thumbs up. Locked in. My major was chemical engineering. Okay, so now we're given 127 grams, 71.9 grams, and we want grams here. And we're basically going to go ahead and start with what we know. So I'm going to always say step 1, start with what we know. And then I'm going to bypass everything. I'm going to say the molecular weights are given. So let's look up the molecular weights of calcium phosphate. So I'm just going to look up the molecular weights. But if we don't have the molecular weights, guys, does everyone understand how to calculate molecular weights? Okay. You're going to add up on the periodic table all the molecular masses of each of those. Okay. And then add them all together. But I'm going to skip that step for now because I want to focus on the stoichiometry just for today. But if you want an example of how to do that, just check my YouTube channel. I just posted it yesterday. Okay, so I need H2SO4 molar mass as well. So that's 98.08 grams per mole. Guys, if someone's been here last week, what do I always say step 1 is always going to be, guys? If you've been here this week or last week, let me know what you think step 1 is. What do I always say step 1 is going to be? Tips for physics as it's more math-based rather than memorization. Always do practice problems for physics. Always do practice problems for physics or chem. Exactly. Good job, Nadia. Always start with what you know. Always start with what you know. So if you need tips for physics, with what you know. My biggest tip for physics is do practice problems like crazy, man. Like, don't memorize stuff, guys. Don't try to just blindly watch videos on your bed, scrolling. No, that's not going to work. You need to do tons of practice problems and review every single day and log in. So I'm going to start with what I know. I'm going to start with what I have, what's given. So I'm given 127 grams. So I'm going to write down 127 grams of Ca3PO42. If I missed the chat, I'm sorry, but you guys are locked in, so that's good. When I can't understand things in class and I want to do because the problem's in class, what do I do? You have YouTube, you have ChatGPT, you have me, you have the Discord, which is totally free. Tino, thank you for the follow. Yes, we're doing Gen Chem for 10 minutes, and then we're going to switch gears to the winner. So if you want to do a different topic, make sure you vote on the top left. It's hard to figure out without practicing. Exactly. That's why we're here to help you out, twin. That's why we're here every single week to help you out. So you can drop your questions in my DMs or in the Discord. And if you want to join the Discord, it's totally free. Okay. So now I have, this is going to be grams of calcium phosphate. And now how do I convert this, guys? What do I want to convert this into? I want to convert this into moles, right? So if I want to do this in grams, how do I going to convert this into moles? Okay. I'm going to basically take my 127 grams. Okay. Excuse me. That's what I started with. I'm going to take my molecular weight. Which is 310.18 grams per mole. Guys, does everyone understand how I got grams on the bottom here? Okay, I basically took my molecular weight and then I'm going to divide here. I'm not going to multiply, I'm going to divide so I can cancel out my grams. So I'm going to cancel out grams and grams. And then I'm going to take my 127 divided by 310. Okay, 310.18. Okay, 0.409. So I got 0.409 moles. Okay, so that's going to be my moles of calcium phosphate. Guys, does everyone understand how I got 0.409 moles of calcium phosphate? If you understand how I got that, go ahead and drop a thumbs up. If you got lost at any point, go ahead and drop a crying emoji. and let me know what part I got confused. Pearl, yes, you want to cancel out the grams so they go at the bottom. Good job. Guys, maybe I'm saying it wrong. For example, when I'm in class, how do I understand it better? Notes? Yes, try to pay attention, Meredy. Try to take your notes carefully, and then don't be afraid to ask your question. Ask questions to your teacher when you're in class. Don't be afraid to ask questions to your teacher. Nadia says, "Your TikToker, thumbs up, Pearl. Good job, good job." Lucy says, "Crying, Lucy." So, guys, can someone please help us out here? So, what part was confusing here? I started with what I know. And I'm going to start with 127 grams divided by the molecular weight, which is 310 grams per mole. Thank you everyone for the thumbs up. And we're going to do the same exact thing, but now let's try again, okay? So, Lucy, if you didn't get that, let's try this again for H2SO4. So, I'm going to start with what I have. I have 71.9 grams of H2SO4. So, I'm going to start with 71.9 grams H2SO4. Now, I want moles, so I'm going to go ahead and divide by the grams per mole. Okay, so what's my grams per mole for H2SO4? Is 98.08. Okay, so I'm going to divide by 98.08 grams of H2SO4 per mole. That way I can cancel all my grams and I'm going to get moles. So I'm going to do my 71.9 divided by 98.08 and I'm going to get 0.733. Okay, so now I got 0.733 and now I have my moles of H2SO4. Same question, my friends. Does everyone understand how I got moles of H2SO4? If you understand how I got moles of CaPO42 and moles of H2SO4, go ahead and drop another thumbs up. Lucy, divide by the molar mass. I'm never afraid. It just doesn't really click. Okay, Meredy, I hear you. If you're still here, I'm not ignoring you. I'm just kind of locked in. What do you focus on when you're taking notes? Like being ahead, I'm super behind. If you're feeling behind, I want you to be patient with yourself, okay? It's gonna take time to understand the content. Okay, if you're not afraid to ask questions, good. Keep doing that. Okay? Follow along here. Okay, try to follow along during today's lecture. Okay, don't be watching this blindly on your bed, scrolling on your bed. No. Guys, actually get out your notes if you're taking Gen Chem right now. Quick question, who's taking Gen Chem right now? If you're taking Gen Chem right now, or AP Chem, or Honors Chem, say me, say here, say locked in so I know that we're... Let me see who's actually taking it right now. Okay. Gen Chem, then multimole ratio of both compounds, exactly. Okay. Okay, so some people are taking it. Okay. Okay, guys, so now we have started with what we know. We converted moles. Now step 2 is going to do a mole to mole conversion. Guys, only 3 minutes left on the clock. If you want me to do your questions, make sure you vote on the top left of the screen. What topic should we should we work on today? So vote on the top left hand of the screen. Make sure you tap the top left. Invite your friends to the live and make sure that you guys vote. Right now, let's see who's cooking. There's only 3 minutes left today. Okay, we're starting off with Gen Chem and there's only 3 minutes left today. Who's cooking today? So we're going to convert moles to moles here. So how do we convert moles to moles? This was the confusing part for me, guys. I actually have a PhD in chemical engineering, and actually this was really confusing for me. Okay, can you believe that? Can you believe that a PhD in chemical engineering actually didn't understand stoichiometry? So stoichiometry was actually really hard for me, okay? So the stoichiometry means I have my molar ratios of each of these here, right? So as long as I balance this correctly, that's going to be basically my molar ratio. So I'm going to start with what I have here for calcium phosphate, and then I'm going to convert to moles of product. Remember, we want moles of phosphoric acid, so I want moles of reactant first. So I'm going to start with my 0.409 moles of CaPO42. Okay? So where did I get 0.409 moles of CaPO42? I just calculated. That was the first thing that we did. We calculated moles because we had grams. All right. Now, I'm going to put some numbers over here, guys. I'm going to put some numbers down over here. It's going to be my mole to mole ratio. Question, what numbers am I going to put over here? What numbers am I going to put down here based on the reaction here? So here's my reaction. What numbers am I going to put over here for the molar ratio? Comment down below. TikToker said 1 to 2. Lucy said, see how many moles of products compared to the reactants. Exactly, right? Good. So how many moles of products do we have? what's gonna be my stoichiometric coefficient? I'm gonna highlight this so everyone can see it. So I'm gonna go to my reaction and I'm gonna start with CaPO42. So I'm gonna highlight my CaPO42. If there's not a number here, there's an invisible one right here. If there's not a number, there's an invisible one right over here. Okay, so I'm gonna put a 1 mole for my CaPO42. Okay, and then TikToker said 1 to 2. So TikToker said 2 to 1. Okay, I can definitely do dynamics. We're gonna multiply by 2. Where did I get my 2? Because I have 2 moles of H3PO4. Guys, does everyone understand why I did 2 moles of H3PO4? Let me know. Okay, so I did 2 moles of H3PO4. That's gonna be this 2 right here. Okay, I'm blocking that. Let me make this bigger. So let's make this bigger. There we go. So that's my 2 moles of that guy and 1 mole of this guy. And I'm going to take my 0.409 and I'm going to take my 0.409. I'm going to multiply by 2. So I'm going to get 0.818. 0.818 moles of product form. That's going to be now moles of product form. Guys, does everyone understand how I got 0.818 moles of H3PO4? If you understand how I got that, go ahead and drop a thumbs up. If you got confused or you disagree, drop a crying emoji or a pot emoji. Can you do like when the numbers have the symbol and the mass number? Hey, Twin, I have a video on that on my YouTube channel that you can check out where I go over the periodic table. Let me hide that so we can see that. We're taught in nursing for meds, but I don't get it. Just do the arithmetic normal. I'm having trouble with that to find them when 2 are missing. Twin, I really want you to check out my YouTube channel because I actually have a video that goes over that, guys. Let me just do this shameless plug real quick. Okay, so go to my YouTube channel and then you can check out the video that says, basically it's talking about like the periodic table and stuff like that, okay? So bring that up here and there we go. Okay, guys, so check this video that says valence electrons, Lewis structures, and the periodic table and things like that. Okay? Alright guys, so let's see how we're doing here. Back to the stoichiometry. Here. Alright, and cool. So we basically got 0.818 moles of H3PO4. So I don't see too many crying emojis, so I'm assuming we're good, but I don't see too many thumbs ups either. Guys, are we good on the 0.818 moles? Okay. Cool. How do you get the 1 and 2? So the 1 and 2 comes from the stoichiometric ratio here. So the 1 is from this one and the 2 is from this 2 right over here, okay? So again, that was like the hardest part for me, guys, in college when I was taking this, okay? Okay, all right, so what I'm going to do next, guys, is basically I'm going to do the same exact thing, but I'm going to do for my moles of H2SO4. So I'm going to start with my 0.33 moles of H2SO4. Okay, and then guys, let's check the pole. So how are we doing here? How are we doing on the pole? So I'm about to convert that into moles of product, but let me know while I check the pole what I should do here. What's the very next step I gotta do here for moles of product here? Okay, what's the very next step I gotta do here? So the winner was Gen Chem again, guys. So I think because I've been doing so much Gen Chem, I'm getting lots of Gen Chem. So guys, we have been live for about 15-20 minutes so far. If you're new here, welcome into the chat. My name is Dr. Andrew Sanchez. I do have a PhD in chemical engineering. If you're new here, comment the word new so that we know that you're new. And if you've been here before, comment another lock-in emoji because we are locked in. We got 7 votes for Gen Chem, so W Gen Chem. If you think Gen Chem is a good emoji, a good topic, drop your favorite chemistry emoji because we're going to lock in for Gen Chem for 1 more hour. Okay, so if you think Gen Chem is a good topic, get out your Gen Chem emojis and lock in emojis because we're about to lock in. Okay, if you're watching this on your bed, get off your bed, get out your notes, and get out your calculators if you're taking Gen Chem right now. Organic chemistry was 4 votes, so maybe we'll do OChem tomorrow. So if you want to do organic chemistry, make sure you vote that tomorrow. Invite your friends. Physics was 2 votes and calculus was 2 votes. Guys, if you want to join the Discord, it's totally free. Join up on the link in bio. That is engineeringminds.co. Last but not least, you can sign up for tutoring. Guys, Gen Chem 1, so let us keep it going. And then I'm going to hide this. And we're going to basically keep it going for another hour. Super excited to be here. Super excited to be here. I'm live every single week, Monday through Thursday, to do live free tutoring. Okay, so guys, what was the next step here? What was the next step? I'm not live every day. I'm live every single week. Nadia, thank you for the emojis. Ava, welcome in. EDW, welcome in. Okay, and so we have our moles of H2SO4, guys. So what we're trying to do is convert our moles of H2SO4 into moles of product. So here's all the reaction here. Here's all the reaction here. So I gotta go back to my recipe. Remember, whenever you're doing stoichiometry reactions, think about recipes, okay? If you don't know what I mean by recipe, I mean go back to my live stream video on my YouTube channel. And I know that in my recipe, I call for 1 mole of Ca3PO42 plus 3 moles of H2SO4. So if I want to convert moles of H2SO4 into moles of H3PO4, what numbers am I going to put over here in my recipe, guys? What numbers are going to go over here? Okay, comment down below what numbers I should put over here on the bottom side here for my calculation here. Okay, so what numbers am I going to put over here? So I'm going to go to my recipe. This time I'm going to highlight this in an orange. So I'm going to highlight this in an orange. I'm going to put 3 moles. Okay, whoops, I kind of gave it away. Whoops, let me go back here. Let me see. Okay, TikToker said 2 and 3, Gorilla 2 and 3. Robert said 1 and 2. So Robert, you did the one for the first one, calcium phosphate. So we did that 1 and 2. But now we're doing sulfuric acid, H2SO4. Good job, Morgan. Good job, Nadia. So let's go ahead and put our 2 to 3 ratio. Notice I'm putting a 2 here on the bottom. Okay, I'm telling you guys, when I was taking this stuff in high school and college, I was so stressed out. I had no idea how to do that. And now, several years later, here I'm out here doing out these live streams because I know what it's like to get cooked for midterms and finals. So I'm going to do my 0.733 times my 3 divided by 2. That way I can cancel out my moles of H2SO4, and now I have moles of calcium sulfate, right? So that's going to be 1.099. It's going to be 1.099. Now, the only thing is I got something different than what I got earlier. So I'm a little concerned that I'm doing some math mistakes, but hopefully I'm doing all this good here. Okay, so I got 0.818 moles of H3PO4 and 1.099 moles of H3PO4. Okay, so if you understand how I got the 1.099 moles of H3PO4, comment a thumbs up so that we know we're on the same page here. If you agree that we got the 1.099 moles of H3PO4, comment a thumbs up so I know that we are still good to go here. While you guys are doing that, let me just double check my molecular weights because I'm a little concerned these numbers are not familiar. So H2SO4 is indeed 98. Did I balance it correctly? Let me double check that I balanced it correctly. I have C3 and then I have 3Ca. That's good. I have P is here 2 and 2. And oxygen, I should have 8. Okay, 8 plus... Okay, guys, we have a problem. We have a small problem. I think I balanced this incorrectly. So I have a 4 times 2 for oxygen, and then a 3 times 4 for oxygen here. So that's 8 plus... No, that's going to be a 12. No, that's good here. 8 plus 12. Never mind. Maybe we are good, chat. I'm not sure what feels wrong here. 3 times 4 is 12, and then O is 8. 8 plus 12 is 20. So we are still balanced. Okay, I'm going to keep going, assuming that my calculations are correct, but something feels slightly off here. Okay, but aren't you doing SO4 rather than PO4? SO4 rather than PO4. They said they wanted it for PO4, so that's why I did a 2 to 3 ratio. Okay, so I did a 2 to 3 ratio because they wanted is an H3PO4. Okay, it's because it's a new moon king. Thank you, Nadia. I appreciate you. Thank you. And it's October vibes. It's October. So guys, I'm going to keep it going. That's going to be converting moles to moles. Now step 3. So step 1 is start with what you know. Step 2 is convert moles to moles. What's going to be step 3, guys? What's going to be step 3? And then we're going to pull up our next poll for today. Step 3 is my favorite part. Okay. Step 3 is my favorite part because it's going to be to determine the limiting reagent here. Okay, so we're gonna pull up a poll. We're gonna pull up a poll here, and then we basically have 2 options here, right? We basically have 2 options. So I'm only gonna have two limiting reagents. It's either gonna be calcium phosphates, or it's going to be H2SO4. So we determine how much moles of product we formed, right? So we determine how much moles of product we formed. So now I gotta go back and determine my limiting reagent here, H3PO4. So it's either gonna be my moles of calcium phosphate, which we said was 0.818 moles of H3PO4 and 1.099 moles of H3PO4. So you have about 10 more seconds to think about that as I pull up this poll here. So if you think that CaPO42 is limiting, you're going to vote for happy face emoji. Okay, and if you think that H3PO4 is limiting, you're going to vote for a crying emoji. Okay, so 60 seconds on the clock. If you think that again, if you think that CaPO42 is limiting, you're going to vote for a happy face. If you think that H3PO4 is limiting, you're going to vote a crying emoji. Okay? So guys, make sure you vote up on the top left. We basically determine our moles of product formed. Okay, good job, Leslie. Leslie said calcium phosphate is limiting. Can you go over finding total ionic equations next? Okay, that's a fun one. So that's probably going to be the next topic. That's going to be the next suggestion. We can do that. And shouldn't you convert both to the same? You use the mole ratio of calcium, not the correct one. I use the mole ratio of calcium. Calcium. Oh, wait a sec. Guys, I see. What did I do? Guys, I made a mistake here. Wait, let's see. Yeah, I did. Hold on a sec. Let me stop this. Sorry, chat. The new moon thing is like messing me up, guys. Let's do that one more time. No wonder, something fell off. Okay, so down here, this should be a 3, and this should be a 2. Oh my gosh, now you can learn from my mistake. Because I just made a very, very common mistake where I switched my molar ratios. So the 3 gotta go down here. Apologies, chat. The 3 gotta go down here. Why? Because I want to cancel out this 3. The 2 gotta go up in here. Okay? My bad, chat. Flip the ratio. Thank you, everyone. Guys, what would I do without you? So now I'm going to do that one more time. I'm going to basically recalculate. No wonder something felt kind of off. Something fell off here. There we go. I got a 0 point. There we go. Now this makes more sense. 0.488 moles of H3PO4. Okay, sorry, chat. Thank you for that. That's how you know that these are real live. Like, I'm literally doing these live. Okay, there we go. So we should be good here to go. Let's do that one more time. Let's run that back. Okay, let's run that back. So which one is limiting now? Hopefully now everyone can see which one is limiting. You still need to change the CaSO4. Oh my gosh, guys, what is going on? I'm getting cooked today. H3PO4. There we go. Okay, now we have the poll active. So we got 0.818 moles of H3PO4 and 0.488. There we go. Okay, 60 seconds on the clock. So once again, happy face emoji for H3PO4 and crying emoji for CaPO42 and crying emoji for H2SO4. If you think that CaPO42 is limiting, you're going to vote for a happy face emoji. If you think that H2SO4 is limiting, vote for that crying emoji. Okay? Thank you, guys. Thank you. What would I do without you? There we go. We got 2 votes so far. 2 votes for crying. We got 1 vote for happy face. 5 votes for crying. Okay. Empirical versus molecular. Let's add that to the list. While you guys are voting for that, let me add that to the list. Guys, we're gonna do Gen Chem for about 45 more minutes, and then if you want to do another topic, just shoot me a DM or sign up for tutoring at the link in bio. Okay, guys, so let's see who's cooking up. Okay, guys, you guys basically crushed that. So we got 10 votes for H2SO4. Okay, we got 10 votes for H2SO4. So if you voted for H2SO4, good job. Everyone drop some party emojis, some woo-woo emojis, and drop some thumbs up. Okay, if you voted for happy face, don't worry, good job anyway. Okay, so, and if you voted for H2SO4, why did you say H2SO4? Why is H2SO4 limiting? Okay, comment down below. What is the reason? What is the main reason why H2SO4 is limiting? Okay. Okay, the lowest number, exactly, right? The lowest number. So let me hide this. Okay, the lowest number. So we basically go back to what we formed. So when we formed, this was our moles of product form, right? Compared to moles of product form. So therefore, we're going to ignore this because this is now in excess, okay? So now H2SO4 is limiting, okay? Now we're going to do step 4 now. So we finished step 1, start with what we know. Step 2, convert to moles. Step 3, determine limiting. Now we have to convert moles of product into grams. Okay, convert moles of product into grams. Okay, there we go. So we got to use our moles of product, and so we're going to select 0.488. Where did I get the 0.488? I calculated it from the original moles. Okay, so 0.488 moles of H3PO4. Okay, so how do I convert this into grams now, guys? How do I convert moles into grams? Okay, perfect. So I'm gonna be, yes, we're given actual yield TikToker. We're gonna do that next. We're gonna do that. Okay, molar mass, good, good. All right, guys, so what's the molar mass? I already gave you that. Okay, the molar mass, actually, I gotta give that to you. So someone either can calculate it, or I'm just gonna just look it up so I can save time here. So I'm gonna look up H3PO4 molar mass. Okay, it's gonna be given for H3PO4 phosphoric acid. You either calculate it or look that up. It's gonna be 97.994, right? 97.994 grams per mole. Okay, so we're gonna do a 97.994 grams per mole. So that way, again, I can cancel out my moles and I can get that here. Guys, we're almost done with this question. We're almost done. So as soon as we get the final answer, let's drop some party emojis, some fire emojis. So 0.488 times 97.994, and I'm gonna get 47.821. Let's see, let's see, that was 47.821 for 0.88, that was limiting. H3PO4, wait, let me see, H3PO4, yep. So let's see what that's going to be. 47, okay, 47.821. 47.821 grams of H3PO4. And we're done. Okay? It took a while, but if you patiently go through it, that's how you do these reactions. And if you miss any part of that, you can rewatch the live stream that I'm going to post it tonight. Okay? I'm doing this in my class right now and I have exam on Thursday. Jared, good to see you. Leslie, thank you for the hat and the mustache. I think I missed that, unfortunately. Thank you for the 34 pumpkins, by the way. Okay, sig figs as well. Okay, sig figs. So let's check our sig figs. True, we got to do a sig figs. I see we have 3 sig figs. So I'm going to round that up to a 47.8 here. 47.8 sig figs. All right, awesome. So everyone go ahead and drop a thumbs up if you understand this. Maybe you don't understand it perfectly, but if you were following along and you kind of get it, or at least you're learning, drop a thumbs up down below. Charlie, what's up? Okay. All right. So we got basically stoichiometry. We basically got stoichiometry here, and then yeah, guys. So let's see who's going. What's going to be the next topic here? So guys, we're going to do one more follow-up here. We're going to do one more follow-up, and then we got to basically do one more follow-up here. And then that was part A. So part B is they gave us, okay, so they gave us 46.85 grams was the actual, okay? And then we want the percent yield. So here's our next question, guys. So if this student obtains 46.85 grams of phosphoric acid, what is the percent yield? Okay, what is the percent yield? Yes, this was a word problem. Yes, it was a word problem that I didn't want to write it out. So I'm giving you everything here. So the word problem says if the student obtained 46.85 grams of actual product. Okay, what is the percent yield? So how do we get the percent yield here, guys? What equations do we need for percent yield here? Okay, good. Actual versus theoretical here. Actual versus theoretical. Okay, basically saw actual versus theoretical. Okay, yes, P. I saw solutions. I saw net ionic equations. Okay, I saw some. Okay, actual over theoretical. Okay, actual versus theoretical times 100%. So let's write that down, guys. This is gonna be our next problem. We're gonna switch gears here. Okay, percent yield. Percent yield is going to be the total yield actual divided by theoretical. Okay, times 100%. So what's our actual? So what's our actual here, and what's our theoretical here? So what's going to be our actual calculation here? So what we calculated was a theoretical here, and then 46.85 was the actual here, right? So I'm going to do my percent yield is my actual is 46.85, okay, divided by my 47.8 times 100%. So can someone please calculate down below, what is 46.85 divided by 47.8 times 100% here, okay? Okay, yeah, I'm going to drop this problem in the Discord, twin, okay? I'm going to drop this problem in the Discord. So if you want to join the Discord, make sure you join up on the link in bio. Okay, so 46.85 divided by 47.8. So someone please calculate that out. Let's see what we get here. 46. Okay, 46.85 divided by my original 47.821072. So I got 98. Okay, I got 98.5%. Wait, let me see. Let me just double check that was the right number. 46.85 divided by 47.821. One more time. I'm going to do this as 0.821. Okay, I got 97.9%. Okay, I got 97.9%. With sig figs, that's going to be 98.0%. Okay, so the final answer was about 98.0%. Awesome job, everyone. So if you were following along and you're learning something, go ahead and do me another big favor and drop a thumbs up, drop a fire emoji, drop a cook emoji, because we are cooking it up today here. Okay. So what is the pH of this solution if it's 1 molar? What is the pH of this solution if it's 1 molar? Okay, if it's 1 molar, what is it? 1 molar H plus? Okay. I'm seeing a lot of requests for a KSP. Okay. Why is it not 97.9? It's 3 sig figs. Oh, if it's 3 sig fig, but the other one was a 9, so it was 97.99. It was 97.99, I think. 97, yeah, it was 97.96. So this is gonna round this up. So 97.96 is gonna round that up to 98%. Okay. Cool, everybody. So guys, we're gonna do our next problem. So comment down the next topic that we should do here. And we're basically, I saw net ionic equation. So we can do A. We can do A is the same topic. Okay, A is the same topic. A is the same topic. That's gonna be stoichiometry. So make sure you comment down below which topic we should do. Okay, same topic, stoichiometry. Okay, B is gonna be net ionic equations, because I saw someone say that earlier. I think I missed someone else say something else. Unfortunately, I missed that. So I'll try to get that down next time. The third one I saw was KSP, and then D, I'm going to put other. If you're saying like, hey guys, switch topics, say like change classes. Math, OChem, physics. Okay. So guys, let's go ahead and do another vote. So this time we're going to do another 60 seconds on the clock. You're going to vote for A if we want to keep doing stoichiometry. You're going to vote B for net ionic equations. Make sure you invite your friends. Make sure you comment down which one you want to do next. So let's do 1 minute on the clock. And we're going to do which is the next topic. Let's do 3 minutes. Let's just do 3 minutes so I can read that chat and see what's the next one to do. Okay, it's 33 minutes on the clock starting now. So make sure you vote for A if you want to continue doing stoichiometry, B if you want to do a different topic. make sure you vote for D if you're saying enough Gen Chem for today, twin. Make sure you vote D if you want to switch to another topic, which the next one was on the list. The next one was OChem. And guys, don't worry, if you missed any part of this, I am recording this entire thing. So make sure you sub to my YouTube channel and you can watch the whole thing. Okay? And guys, how's everyone doing? Do you guys have midterms, finals? How's everyone surviving this quarter? Okay, how's everyone like feeling about Gen Chem, OChem, math, physics? Is everyone still surviving, or are you feeling totally cooked? Are you cooking this semester, or are you getting absolutely cooked here? Okay, by around this time, I know it's like October vibes. So in October, I know it's super overwhelming and super stressful here. Okay, thank you, Nadia. Y'all gotta click on the clipboard and vote. Exactly, y'all gotta click on the thing on the top left here. So right now we got 2 votes to change topic. We got 2 votes to change topic, and the next one will likely be OChem, because that's gonna be what everyone was saying earlier. Obviously, Gen Chem is hard. I know, twin. That's how I felt too. I'm not gonna lie, guys. Believe it or not, I struggled so much with Gen Chem and physics and calculus. Okay, so that's why I'm out here, because I know what it's like. Alina says barely surviving. You got this. Nor says all right. Lucy says, oh, I'm cooking. Oh, I'm cooking. All right. Angelic says, I just booked tutoring. Awesome. Thank you. Thank you. Looking forward to meeting with you. Angelic says, okay. Guys, it seems like we got 5 votes for changing the class. So we're probably going to switch gears here to organic chemistry, unless you tell your friends to vote for a different Gen Chem topic. Okay. And so, yeah. TikToker, how is Physics 1 calculus based? I'm taking it next semester. Physics is calculus based. How's Physics 1 calculus based? Physics, to me, guys, I'm a proponent of calculus equals physics. I'm a big proponent of, if you're doing calculus, you're low-key doing physics in disguise. Okay, and vice versa. If you're doing physics, you're actually doing calculus in disguise. So don't be scared. Make sure you review your trig. You're going to need a lot of trigonometry and functions and limits. Okay, cool. Thank you, Leslie. Thank you. Nadia says physics. Okay, guys. So I'm going to go in order. So last time, the first winner was Gen Chem. So that's why we did Gen Chem for about an hour. And then for the next 30 minutes, we're going to go down on the next topic, which the winner was, drumroll, 3, 2, 1, organic chemistry. So guys, we're going to do organic chemistry next. And the first request I saw was substitution and elimination. So super common question that I have here. So guys, if we're ready to lock in for organic chemistry, aka substitution and elimination reactions, go ahead and comment a thumbs up or a lock emoji if that's a good topic. Okay? If that's a good topic, go ahead and comment down that thumbs up emoji so we can see what we're gonna do here. Okay, super common question. You're definitely gonna see this on your midterm. And guys, shameless plug, I'm gonna post an organic chemistry video this Friday. Actually, it's already up on my channel, but I've only released it to the Discord members. So if you want to watch the latest OChem video, make sure you join the Discord or sub to my YouTube channel, because it's coming out on Friday. And guys, I'm going to try my best to build out this course this semester for organic chemistry. So if you're taking OChem this semester, let me know with a comment down below. Guys, let's see if substitution and elimination is a good reaction here. What are the prerequisite classes for OChem? General Chemistry 1 and 2. Okay. TikToker, we just went over nucleophilic addition to aldehydes and ketones. Oh, you're much ahead. You're much ahead, Angelic. So this is gonna be review for you. Okay. All right, Red Bow, welcome back to taking organic chem. So guys, let's start with SN reactions here. And so this is one of my favorite topics to teach, because this is going to be our skits. So if you've been here before, you know that we have our skits here. So check out my skits on IG and TikTok. I used to watch a lot of Nickelodeon, so I'm really inspired to make some skits, because OChem is literally the study of rhizology. As soon as you make OChem fun, that's how you're gonna start cooking, because organic chemistry is the study of rhizology, literally. What do I mean by rhizology? I mean literally we have a nucleophile that's gonna come in and riz up this leaving group here, and the leaving group is going to leave. Okay, so guys, here's going to be our first reaction. This one's going to be called SN2. So try to make OChem fun, because that's how you can lock in and start to actually enjoy it. Okay guys, so this is called an SN2 reaction. So SN2 reaction means we're gonna have a nucleophile. So nu stands for nucleophile. So guys, what is a nucleophile? Can someone tell me what a nucleophile is? What does phile mean? Can someone tell me what is phile? What does the suffix phile in English mean? What does phile suffix indicate? Wombology, exactly. Wombology, you get me. You get me. So phile means to love, right? Phile means love of. Okay, for example, pedophile, heliophile, electrophile, nucleophile. So that means love of. What about nucleo? What about nucleo? What lives in the nucleus? Period says lover, exactly. Electron loving. Okay, so nucleo. What lives in the nucleus? What lives in the nucleus? Is it what's gonna live in the nucleus of an atom? Exactly, love of nucleus. But the nucleus is positive charge, so it's gonna be love of positive. It's going to be love of positive charge. Love of positive charges here. Okay, so typically a nucleophile is negative, and negative is attracted to positive. Literally, opposites attract. So if you ever have a crush on someone, you're going to want to be attracted to them. So literally, nucleophile is it has a crush on this guy here. So we're going to say our nucleophile is our Riz boy. Okay, and so if you don't know what I'm talking about, check out my skits on TikTok, guys. They're super fun to make. Okay, so the nucleophile is our Riz boy, and so the Riz boy is gonna go like, "Hey, baby girl, I'm gonna come in and go right here." Okay, so that's gonna be called nucleophilic attack. It's literally like, "Hey, baby girl, can I get your number?" Okay, and that's called nucleophilic attack. That's gonna be step one, simultaneous reaction here. Okay, so there's gonna be our "Hey, baby girl" kind of step. Can I have your number? You know what I'm saying? All right, and then step two, here's our leaving group. So the leaving group is already okay, that's the boyfriend, and then the girlfriend says, "Don't worry about him. He's just a friend." Okay, but the leaving group says, "You know what? This is toxic. I'm out." Okay, so step two is loss of leaving group. Loss of leaving group. Okay, so the Riz boy is basically Mr. Serial Girl. He's saying, "Hey, you know what?" She's saying, "Hey, you know what? Don't worry about him." But the leaving group says, "You know what? This is a toxic relationship." So SN2 is your typical toxic relationship reaction. Literally, as soon as you make OChem fun, it's going to start to be so much more fun. Okay, so let me get rid of one of these methyl groups here, because I only want that to be secondary. Okay, perfect. So at the end of the day, my leaving group left, and he's angry. So my leaving group is angry. That's why he has a minus charge. So the leaving group is upset. That's why he's negative. And then now we're going to make our nucleophile up on top here. That caused a new reaction here. So this was our toxic breakup story here. Okay, any questions here? Okay, someone said backshot. That is not wrong. This is called backside attack. So someone said backside attack. Guys, OChem is literally rated R. Okay, someone said backside attack. Let's do PG-13, guys. Let's do PG-13, because I don't know who's watching this. Okay, OChem being fun is impossible. I have a proton I want to give you. Exactly, right? I hate that this is making sense. Why do you hate that? Shouldn't that be a good thing? Okay, any questions about SN2? This is literally SN2 here. Any questions about SN2? And then we got to do the same thing, but we got to do some examples here. Okay? We got to do some examples here. And then we got to basically see which one's the next step here. So, let me get another example here, guys. Let me see what's a good one here. So is elongation during the key. Guys, I'm not that good at biochemistry, unfortunately. I'm not that good at biochemistry. So let's do an example that we can see this together. We can see SN2 in action. Okay, let's do an example here that it's going to say something like this. It's going to say predict the major product of the following SN2 reactions. So we're going to predict the major product of the following reaction. And we basically have this compound here. Okay, and so our compound is going to be this compound right over here. And so this is a cyclohexane here, and let me just fix that here. Our bromine is going to be wedged just like that. And guys, like I said, I'm having a YouTube video coming out this Friday where I go over all the cyclohexane examples here. So make sure you sub and check that out this Friday. Okay, and then we have NaCN. Now, the first thing we have to do is identify which one's the leaving group. Which one is the leaving group? Which one is the person that is the original couple? Which one's the couple? And which one is the guy that she told us not to worry about? So which one is the leaving group and which one's going to be Mr. Stereo Girl? Okay? Okay, bromine is dashed. Okay? Sodium cyanide, good. Okay, so which one's which though? Which one's which? Okay, good, good. Okay, I meant to say bromine is dashed. Okay, and then methyl is wedged. So we're gonna say bromine here is our leaving group. And so typically our halogens are good leaving groups. Okay, halogens are good leaving groups. Why? Because they are highly electronegative. They can be basically stable in solution. Okay, so basically bromine is going to be a good leaving group here. And guys, by the way, this is something that I've been going over every single week with my organic chemistry group course, okay, where I lead a small group of students doing organic chemistry and making it fun and easy and educational. So if you want information on how to join, just shoot me a DM or check out the link in bio, engineeringminds.co. Okay, and so we basically have our NaCN here. This is going to be our Cn minus. Okay, our Cn minus. This is going to be our nucleophile now, right? So this is going to be our nucleophile. So our nucleophile is going to attack. Okay, our nucleophile is going to attack. Where is it going to attack? Let's do a quick poll. Okay, I'm going to say it's either going to attack here at A or here at B. If you think that it's going to attack at A, you're going to vote for a happy face emoji. If you think it's going to attack at B, you're going to vote for a crying emoji. So our Cn minus is going to act as a nucleophile. Give me about 5 more seconds to pull that up. Okay, and we have our quick poll. Okay, 60 seconds up on the clock. So if you think that Cn minus is going to attack the A side of that cyclohexane, you're going to vote for happy face. If you think it's going to attack the bottom side, you're going to vote for the crying emoji. Okay, we got 2 votes for happy so far. Good job, good job. All right. Okay, good job, good job. So we got 4 votes for that A. And if you don't know, just guess. There's no wrong answers. Just guess here. Okay, very good, very good. Good job, Angelic, Kelly, Josh, Goat, S. Okay, everyone's saying A. Guys, if you said A, why is it going to be A here? Okay, if you said A, you are correct. Okay, keep voting though, keep voting. The correct answer is A. Let's keep it going. So we're going to have our nucleophilic attack. Okay, that's going to be our nucleophilic attack. Okay, and then this is going to be our loss of leaving group step. Okay, this is going to be a concerted reaction. So this is going to be our nucleophilic attack and loss of leaving group. Again, that's basically Mr. Stereo Girl coming in and swooping in. Wow, everyone cooked that. We got 7 correct answers. Nothing was incorrect. So everyone cooked that. Good job. Okay, everyone dropped some party emojis. All right, now the last thing we got to do is basically we have to determine the stereochemistry, the orientation of that Cn. So one more question, guys. If you think it's going to be dashed, if you think the Cn is going to be dashed, you're going to vote for another happy face. If you think it's going to be wedged, again, you're going to vote for another crying emoji. Let's do one more quick poll. Ready? And 3, 2, 1. 60 seconds on the clock. So we basically are going to have our Cn right here. So I'm going to put a Cn right here as a placeholder. Okay, that's our cyanide group. Now, it's either going to be dashed or wedged. Okay? If you think it's going to be dashed, vote for a happy face emoji. So remember, it was dashed. But if it's going to be wedged, you're going to vote for a crying emoji. How do we determine that orientation? How do we determine that orientation if it's going to be dashed or wedged here? Can you please clarify why it's Br? Can you please clarify why it's Br? Oh, because Br is the leaving group, and so nucleophiles always attack the leaving group. Okay, nucleophiles always attack the carbon right next to the leaving group. When we do our backside attack, our nucleophilic attack, the Cn is always going to attack the carbon right next to the leaving group. So guys, this time we got 4 votes for dash because you guys said dash. However, The reason it's called backside attack is because it's going to be kind of like this. Remember in our couple analogy, we basically had a boy and a girl, right? Or it could be in a girl and a girl, or it could be a guy and a guy, or non-binary, non-binary. I'm not here to judge, okay? So we basically had, I'm just going to use a girl and a boy analogy, but the genders don't matter. It can be whatever gender you want, okay? And so notice that here it was on the left and here it was on the right. But when Mr. Stereo Girl came along, he basically flipped the orientation. So now watch this here, okay? So this was our nucleophile, and it's gonna come in and basically replace that original boyfriend here. Okay, so now the girl is actually now on the right side and the boy is actually on the left hand side. So we have to flip the orientation of the CN. Therefore, it's actually going to be wedged. Okay, so that's called backside attack. That's called nucleophilic backside attack. Okay, so that's why we vote for wedge. In other words, we started with dash and then we're going to change that to wedge. Let me know if that made sense, okay? Let me know if that made sense. Why did you say crying for wedge? Why did you say crying for wedge? I don't know, just to make an A-B test here. The negative charge on the N and the carbon makes it electrophilic. Nucleophilic. Yeah, that's going to be nucleophilic. Yep, it's going to be nucleophilic, okay? Is it always the opposite? Careful with the word always in OChem, because always, you already know there's tons of exceptions. But generally, yes. Generally, it's going to be opposite orientation, but just careful with your exceptions here. But generally, it's usually going to be, okay, that. Okay, so that was our SN2. That was our SN2 reaction, guys. We're going over SN2 reactions, and we're gonna do elimination next, okay? Why doesn't the wedge, ooh, great question. Why doesn't the wedge in the bottom turn dash? Because nothing happened over here. This was just hanging out, okay? This was just the friend that was watching the whole thing go down. This was just the BFF just watching the whole thing go down. She didn't change, okay? The BF was just hanging out down. In other words, there was no reaction down there at that pair of carbon. There was no reaction, so it's not going to change. Okay, Jackson, good to see you. OChem is back. I know we've been doing Gen Chem, but finally OChem actually won. Okay, actually Gen Chem won again, but then we had to switch it to OChem. So guys, that's our SN2 process. Next is going to be SN1. Okay, SN1 is going to be our next example. So SN1 is going to be our same idea here. Okay, we're still going to have the same idea, but I want you to realize that SN1 is a stepwise. Okay, what do I mean by stepwise? For SN2, we did it all in one fell swoop. That's called concerted. Concerted as in the word concerto, as in like a very nice, concerted, organized chemical reaction. Okay, but stepwise means that we got to do this in several steps. Okay, so let's do SN1 together. My PhD was in chemical engineering. Okay, my PhD was in chemical engineering. So for SN1, we're going to basically do a tertiary here now. And here's our leaving group. So this one is kind of similar to our breakup story, okay, where our leaving group dumps, okay, instead of a Mr. Stereo Girl, it's going to be the leaving group leaves first. So step one is loss of leaving group. Loss of leaving group. So basically the couple, one of them got bored and say, you know what, I'm out. Like this is not working out. So that's called loss of leaving group here. So that's going to be our first step. And what's going to be generated is basically a really, really happy couple, a really happy single. So now she's, you know what? I'm happy. I want to be single. I have a positive charge. So now I'm ready to mingle. Okay. So this is called a carbocation intermediate. Carbocation intermediate. So the reason it became positive is because we have a formal charge of +1. Intermediate. Okay, a formal charge of +1. So now our tertiary carbon is now a happy single life. She's single, ready to mingle, and guess who's gonna come along this time, guys? Guess who's gonna come along and basically come in? Here is gonna be our nucleophile. Okay, it's gonna be step 2. I'm gonna do our nucleophilic attack. So our nuke attack is basically saying, hey, I heard you and leaving group broke up. Okay, I heard you and leaving group broke up. And she said, yeah, we kind of did. So then he's going to basically come in and attack this carbon over here and generate our final product, which, by the way, we had our leaving group is minus here. So this one was kind of like another toxic breakup, but it wasn't as toxic as like the cheating scandal. It was just basically a breakup story and then a quick rebound relationship. Okay, so that is called SN1. So the main thing for SN1 is it's stepwise. Okay, stepwise means that we have this in two steps. Step one is first loss of leaving group. That's going to be the breakup, and then step two is the nucleophilic attack here. Okay, exactly. Nucleophile is the rebounder. Yo, chill. Who said that? Who said that? He said, Goat said, if you're the lean group, don't worry, I'll chase you like a strong. Yo, chill. Yo, I don't know if I should. I don't know if I should be. I don't know if I should. Okay, I don't know who's watching this, guys. So we're gonna do an example for SN1. So guys, sometimes for SN1, people get confused because we have to do our proton transfer step. So with proton transfer, just because we're doing SN1, SN2 doesn't mean that we can ignore the acid as tell them to lock in. Yeah. Okay. Move it to the side. Oh, my bad, twins. So move it to the side. What do you mean? Can you guys see that? Okay, take a screenshot of that. Guys, remember, I'm recording all of this, so if I miss something, oh, that's what you mean. Okay, I see what you're saying. It's like kind of like out of the way. Okay, there we go. Let's make it bigger like that. There we go. So yeah, bro, lock in. I don't know who's watching. There could be kids watching this, guys. There's kids on this app. Okay, so that's gonna be our SN1 reaction. So let's do an example here. We have this OH here. Okay, so OH is a bad leaving group. OH is a bad leaving group. Okay, so before we make OH do our reaction, we have to kind of like get it ready. We have to get it ready here. Okay. Okay, you're in med school, so this is review. Okay, so he doesn't need to lock in. Okay, no worries. So we have basically acid plus methanol. Okay, acid is our hint that we're gonna do an acid deprotonation step. So if you have acid, we're gonna add another step one is gonna be protonation. Okay, so step one is gonna be protonation, protonation. And guys, this is where this is one of my favorite topics also because protonation is going to be an acid-base reaction. So if you watch my acid-base series, you know that I say that acids and bases are like ravers. Okay, and I feel like the raver step is basically a candy trading here. So they're going to kind of like trade candy and basically steal that proton. Okay, so protonation means that we're trading candy because the acid concentration dictates the relative acidity of the solution. Okay, guys, I do tons of analogies because I try to make organic chemistry as fun as possible. Okay, so now we generated a water molecule over here. And guys, is water a good leaving group or a bad leaving group? Let's do another poll. Okay, let's do another poll here. So I have H2O here, and I'm gonna say, is it gonna be a good leaving group or a bad leaving group? And if you think it's a good leaving group, you're gonna vote for a happy face emoji. If you think water is a good leaving group, you're gonna vote for a happy face. If you think it's a bad leaving group, please vote for a crying emoji. 60 seconds are on the clock. Okay, so the question is water a good leaving group or a bad leaving group? Is water a good leaving group or a bad leaving group? Okay, we got 6 votes already for good. Good job. So if you think it's a good leaving group, why is it a good leaving group? Why is it a good leaving group? Is it only halogens that make a good leaving group? No, twin. It's going to be anything that is generally stable when it gets removed. Anything that is stable. So halogens are generally really stable. O-tosyl, OTF, and OTS are also really good leaving groups. There should be a whole table in your textbook or your professor gives you. That's going to be a whole table of all the good leaving groups. Okay, and then if you need one, maybe I'll drop one in the Discord later here. Okay, so good job, everyone. So if you said water was a good leaving group, why would you say that it is? Okay, so our step 2 is a loss of leaving group. Okay, so now basically what I like to think of SN1 is kind of like now we protonated that and we generated water. Okay, and then we're gonna basically generate our new carbocation over here. So guess what's gonna happen now? For SN1, we're gonna basically have our MEOH step. Now, here's the tricky part here. Okay, here's the tricky part. We see this methyl hanging out. We see this methyl hanging out. So this methyl is gonna undergo carbocation rearrangement. Actually, we have this proton here. We have this proton here. So, excuse me, for SN1, we want a tertiary compound. So what do I mean by tertiary? Right now, it's attached to only 2 methyl groups here. Right now, it's attached to 1, 2. So this is going to be a secondary carbocation intermediate. Now, I want to make it tertiary. Why? Because tertiaries are more stable than primaries. So what I'm going to do is I'm going to basically move this proton over here. Okay, so the proton just kind of gets bored and just hops on over. This is going to be a carbocation rearrangement. Carbocation rearrangement. And what's going to happen over here? Carbocation rearrangement. So our proton just kind of got bored and hopped on over, and basically we're going to generate another carbocation intermediate, which is now over here. So guys, is this primary, secondary, or tertiary? So I'm going to ask you, is this primary, secondary, or tertiary? So another poll, another quick poll, just to see how we're doing. If you think that this is primary, you're going to vote for a happy face. If you think it's tertiary, you're going to vote for crying. Okay, and another 60 seconds on the clock. Exactly, it's going to be a hydride shift. Period, good job, tertiary. Oh, I thought it was pronounced carbocation. That's when I thought cations. I thought cations were pronounced cation as well. But cations are pronounced cations because cats have paws and paws are positive. Okay, good job. So everyone said that it's a tertiary carbocation. So I'm going to label this as tertiary. Why is that tertiary? Because I have 1, 2, 3. So that's going to be 3 methyl groups attached to that. And the person that said 2, that's okay. But remember, we do have this methyl that's going to add. So we have 1, 2, 3, and that's going to be our tertiary. Good job, everyone. Okay, good job. So we have one more step. And then we are done. Maybe 2 more steps. Okay, I kind of ran out of room here. So let me just bring this down. And bring this down over here. So it can be overwhelming the first time you take organic chemistry. I definitely understand, but just break it down step by step. Remember, we had methanol. So now methanol is going to be our nucleophile, and methanol is basically a CH3OH. Kind of like water, it's going to come in and attack this carbocation. Just that 3 is in the way. So let me just get this 3 out the way. Okay, and basically bringing that over here. Guys, let me get this 3 out the way like that. There we go. And we're going to basically attack using our nucleophile. So methanol acts as a nucleophile. Okay, and then we ran out of space, so I'm going to draw this really nice and small over here. Let me zoom in and draw this really nice and small, just like that, and like that. Okay, and then like this and like that, and that's going to be an OH plus. And unfortunately, I totally ran out of space, guys. We need to do one more step, which is a deprotonation step. So I'm going to bring all of this down, and then don't worry, I'm going to zoom out so everyone can take a screenshot after we're done. Okay, and then I'm going to go ahead and do my final deprotonation step, which remember, we had water, which water is now going to act as a base and deprotonate that proton right over here. And it's going to eat that proton and stabilize the compound. And beautiful. Now we have our final product. Here. It's going to be OH on the side. That's our final product. Okay, so I know it can feel overwhelming, but let's zoom out here and let's see what we did. Remember, if you make it fun, if you make it like a story, that's the best way to understand this stuff, guys. Okay, and then don't worry, I am recording all of this, and I will post this tonight. Okay, so we started with our original alcohol. So the alcohol went to a party and got a proton here, and now the alcohol basically got protonated and became loss of a leaving group. Okay, so the leaving group decided to, you know what, I'm tired of this relationship, I'm out. Okay, you can be single and I'm gonna be single too. But it doesn't matter because our carbocation is really happy. That's why we have this positive charge here. So the carbocation is nice and happy. It says, you know what, I'm single, ready to mingle. So the first mingling step was called the carbocation rearrangement, whereby the proton moved over and converted it from a secondary to tertiary. Remember, we want tertiary over secondary because tertiary is more stable, okay? And then finally, our nucleophile, aka Mr. Steal Your Girl, came in and attacked that carbocation, generating another compound with this. Finally, a proton transfer occurred to deprotonate that and gave us our final product over here, which was another alcohol like that, okay? This is the substitution chapter. OME, not OH. OME. Oh, snap. What did I do here, guys? OME. My apologies. My apologies. Gotta go back over here. Let's change this to OME. My apologies here. This is OME. OME. There we go. OME. Just like that. Okay, so that was a methanol reaction. Thank you. My apologies. So that was our OME there. Okay. Guys, what questions can I help answer? Any last minute questions? I'm going to be on for about 5 more minutes here. Again, if you missed any part of this, you can rewatch the whole live stream that I'm going to post up on my YouTube channel tonight. Okay, going to be on for about 5 more minutes. Everyone, thanks so much for joining today. Pretty much going to end it shortly, but really hope this was helpful. Once again, my name is Dr. Andrew Sanchez. I do have a PhD in chemical engineering. You can ask me any questions related to math, chemistry, OChem, or physics. Thank you, Jackson. Thank you. No, you. This is SN1, 10. This is SN1. Good question. Okay, I'm really glad. I really hope this was helpful. Yeah, does Gen Chem 2 touch on OChem? Kind of, yes. Yes, because you're going to learn about acids and bases, and we're learning about acids and bases here. Nadia, good question. Okay, great question. So yeah, if you're bad at Gen Chem 2, make sure you review before you start OChem, because you're going to see a lot of the same concepts. You're going to see acids and bases. You're going to see charges, ionic charges, equilibrium. Okay, would RNH2 or RNH be a better nucleophile for a stronger, which is stronger than used in SN2? Ooh, that's a great question. Now you're testing me here. RNH. Well, RNH is not a. Do you mean R2NH? I think you meant a primary amine versus a secondary amine, because RNH doesn't exist. So RNH2 versus RNH. RNH would be minus. So if it's minus, then yes, this is a stronger nucleophile. Okay, I hope you mean RNH minus, I think. I'm assuming you mean that. Okay. Amine shift base formation or writing reactions. Oh, Wittig. Oh, Wittig reaction. Okay, guys. Okay, guys. So pretty much gonna end it here. Thank you so much for joining. Here's all the information. You can sub to my YouTube channel. You can join the Discord, which is totally free. Make sure you sign up for tutoring. I got you for tutoring for math, OChem, physics, and Gen Chem. And again, join the Discord, which is 100% free. So just go to the website, link in bio. Go to engineeringminds.co. Join up there. And yeah, guys, my live stream schedule should be up soon. I go live every single week, Monday through Thursday, 6 o'clock PST, 9 o'clock EST. And yeah, hope everyone is cooking the semester. Okay, hope everyone is cooking the semester. And thank you so much for joining and interacting and commenting. And especially like Leslie for the gifts. Leslie gave me 34 pumpkins, 2 hat and a mustache. We got 44 new followers and 6.8K likes, guys. So super appreciate y'all. I will see y'all tomorrow. Everyone have a great rest of your night. Stay safe and best of luck on the semester. My pleasure, my friends. My pleasure. Peace out. Also, I'm going to be posting this live stream in like 2 hours on my YouTube.